Good evening, everyone. Yesterday, we laid the foundations for working with Python. First, we learned how to install Python, explored its basics, and practiced some mathematical operations. Then, in the second part, we moved a step ahead and discussed data preprocessing, how to handle missing values, and how to work with text files. Now, imagine you have cleaned your raw data, removed the missing entries, and prepared it. But what next? How do we actually analyze large data sets, organize them like Excel tables, and perform operations like sorting, filtering, or calculating averages, all in Python? So that's exactly where today's topics come in. Pandas. Pandas is one of the most powerful Python libraries for data analysis. If NumPy gave us the ability to handle number efficiently, Pandas gave us the ability to handle real world data sets. The data sets can be in the form of numbers, in the form of text, in the form of dates, anything you can think of. In simple words, Pandas is like Excel inside Python, but much more flexible and faster. So, in this session, we will begin by understanding what Pandas is, exploring its two main building blocks, series and data frames, and some basic operations based on it. And by the end, you will see how Pandas can turn messy data into structured information that's ready for analysis. So, Python stands for Python Data Analysis, is an open source Python library which is used for data manipulation and analysis. It consists of data structures and functions to perform efficient operations on data. It is well suited for working with tabular data such as spreadsheets or SQL tables. It is used in data science because it works well with other important libraries like NumPy, uh, and it makes it easier to manipulate and analyze. So pandas is used in other libraries also, such as matplotlib for plotting graphs, scipy for statistical analysis. We have scikit-learn for machine learning algorithms, and it uses many functionalities provided by numpy library also. Now with pandas, what you can do various tasks like you can read and write data from various file formats like CSV, Excel, and we can clean and combine data from multiple sources, handle inconsistencies and duplicates. We can handle missing values, right, in both floating and non-floating point. We can merge and join multiple data sets seamlessly. We can reshape our data through pivoting and stacking operations, and we can also visualize the data with matplot and seaborn integrated with pandas. Now, how to install the pandas? So the first step is when we install it in the system. So we just write this pip command. In the command prompt, we just write pip install pandas and it will install in your system. But that part we will not do because we have already installed Anaconda platform in our system, and from that we have already installed Jupyter Notebook, and in that whole package, we have already pandas and numpy libraries available. So we just have to import the panda module. Okay, so we have to just we will just import this library and using import pandas as PD. The PD is just allies of pandas. If for numpy we will use np, and for pandas we will use PD. Okay, so moving further, data structures in pandas library. So it provides two data structures for manipulating data. First is series. Series, just think of it like a single column in Excel or a list with label. It is a one dimensional, means it can store data in a single sequence. Okay, whether it is a number or whether it is a string, and each value has an index like a label, so we can easily access data by position or by name. So for example, you just assume the column of student marks or a list of product prices. Okay, so that is the series. And when we talk about data frame, it is a two-dimensional data structure. So it is just like a full Excel sheet with rows and columns. Uh, it means it can hold multiple columns and each possibly of a different data types. It can be numbers, it can be text, it can be dates. And we can organize, filter, and analyze entire data sets in a structured way. And also it can be created from list dictionaries. So without wasting any time, I just want you to show my Jupyter notebooks. Just give me a moment. I just want to show you my Jupyter notebook so that we can work there and grab some hands-on sessions. Is this? Wait, just this. I think I'm able to show you. Is it visible? Yeah, I think it is visible now. Okay. So this is a Jupyter notebook. I have already show you yesterday how to launch Jupyter notebook from Anaconda and open that. So I will just give this untitled notebook a name, which is Pandas tutorial. Okay, rename it. Wait. Underscore rename. So first we will see how to create a Pandas series. Create a Pandas series. How we will create that? Shift plus enter. And there are many ways, of course, for creating Pandas series. Let me just the first is when we create an empty series. Empty Pandas series. So how we will do that? We will import first. Import Panda. Import Panda as PD. Then we will create a variable name. Here is PD dot series, and we will also specify the D type so that it cannot confused. Okay, which data type I have to take in future. By default it will take a float value, but it will give a future warning that आगे से ध्यान रखिएगा. So that's kind of a warning. Let me show you that also. Let me just create this. Wait, so that you can easily understand what I want to say. Print serve shift plus enter. Yes. Okay, first of all I have to import this. Okay. Just miss the S here. Yes, see it says this future warning. It gives this future warning. The default D type for empty series will be object instead of float 64 in a future version. So specify a type D type explicitly to silence this warning. So okay, we will silence this. We will write D type is equals to float 64. Float 64. You have already see this. Will give this. It will create this empty series, and it is of float version, float data type. So now we have to create. It is saying na, it will be object instead of data type. Why it is saying? Because yes, in empty series it can be mixed data, it can be string, so that's why. So we just write here object, and see, it create this empty series, and the data type is object. Now the second thing, so that's how we will create an empty series, right? Now the second thing, when we create a series from a numpy array. Now, I haven't introduced right now the numpy array, but it will not as much difficult to understand. We will use import pandas as pt, and because we are using numpy array also, we will import numpy as np. Okay, and we will create a variable name data is equals to np dot array. Actually, this is how you will create numpy array also. You will see in the coming tutorial also. Np dot array, and just give the elements you want to uh, give here. So I will take comma I comma t comma comma o comma Python. Okay, and after that we will create a series, just like we will create above, and here we will write pd dot series, and we will store it in numpy array, no? So we will type here this variable data, and when we print ser and shift plus enter, yes, you can see this series is created from a numpy array. So it automatically gives this indexes here 0 1 2 3 4 5, and yes, it's a list python, and because it contains a string, you can say character, so that's why its d type is object. So I hope you understand. Second thing, when we create a series uh, from a list, so we will import pandas as pd, and we will create a list data list is equals to, you have already learned in Python that in list we just write the elements using this square brackets. So when we write the elements in these square brackets, it will uh, assume as a list, that it is a list. Okay, so just write data. Okay. Simple elements I will store here. Simple elements data, and we'll create a list using the same method, pd.series, and call the variable this function print ser, and you will see here is 0 1 2 3 as the index of the elements, and here is the list data. We have to create a series from a list. Now how we will create, another example we'll take creating a series from dictionary. How we will do this? Import pandas as pd, and we will use data dictionary, and we use this curly braces, and because dictionary is uh, created using key value pairs. I have told you in yesterday video also that it is stored in key value pairs. Key contains the headers, and then whatever the values will be in those heads, it will write accordingly. So just for this example, suppose I have write this is a key, and just give this value of 10, comma, separated by comma, and again Alice, 20, and another name Charlie, 30. Okay, and after that I will create the series pd dot series, and we will call this variable data dictionary, and we print this here series. But it shows the data dict is not defined. Is it not defined? I think it's defined here. Oh, sorry, I have not assigned it. Mistake. Yes, so we have created a series Tom, Alice, Charlie, and here this is the value, this is the key, and this is the value. So this is how you will create a series from dictionary. Okay, another thing, when we will create a series from series using range function. I have told you, no, use range function instead of for loop. We will use this range function where we write the first element as a start, then stop where we have to stop, and then separated by the number of steps incremented or not. No, by default it will increment by 1. So this is how you will create a range function. So it commonly used to generate sequences of numbers. So we will import pandas as pd, and we will what we will do pd dot series, and we will and let's take the number 5 comma 15. So what it means, it means that it will start from 5 and it will end at 14. Okay. uh, let's see when we print this. Yes, it starts with 5 and ends at 14. And when we suppose we want to increment it by some steps, so by default it is taken as it is taking as 1. Now what we want to do when we want to do this, take 3 increment 3 steps. Does Yes, it will print like this: 5, 8, 11, and 14. So this is how you will create a series from various ways. Okay, in pandas. So now we will see we will see how to access the elements from a series. So first of all, we will see how we will access the element from series with position. Okay, and then we will see accessing the element from using label, means index. So this is the ways we will see. Okay, this is the two ways by which we can see. So first of all, we will see how we will access the elements from series with position. So you have already known slice operations. Okay, you have read the slice operation in Python. I will just give you the brief here. What How we can do this? So just in slice operation, slice operation. Let me just give you an overview how we will do this slice operation. So see, slice operation is performed on series, okay, with the use of the colon word. So when I have written here like this, index colon and bracket. So what it means, it prints elements from beginning. Okay, and when I write square bracket, then this column and minus index, so it prints elements from end use, means in reverse, right? And when I write within a range, so I will use start index and I will use then this end index. So it will print the elements from within a range, and when I just write this colon, so it will print whole series. It will print the whole series. Print the whole series. So by performing this operation, you will be able to understand how this slice operation is done. So first of all, we will access the accessing the first element. We will access the first element of series. So we will import pandas as pt. We will import numpy as np, and then we will create simple array. Creating simple array, that is just creating simple array and by numpy dot array, and in this example python take it python, and then we will create a series pd sorry pd dot series, and then the variable name pd dot series, and suppose I have to retrieve the suppose I have to retrieve the first element. So I will write here what? Print zero. Shift plus enter. It will give P. And suppose I have to retrieve first 5 elements. Suppose I have to retrieve first 5 elements. How I will do this? First 5 elements. So I will write here colon and 5. Right. And it will give me first 5 elements. See, I have written here now that 0, 1, 2, 3, 4. It will give me first 5 elements. And suppose if I want to retrieve first 10 elements of series, in my list 10 elements are not there, but let's just see, let's just check what it shows. So yes, again because it will print the whole series. Okay, see, it will print the whole series because the first 5 actually comes in that 10 elements. So in memory, in this memory, his memory, the it will print these values, right? Now we will see how we will access the elements from our CSV file. From a CSV file, we'll see that. So we will first import Pandas as PD. We will make a data frame. Data frame is just like a Excel sheet, you can say. It will make when it gives the output, na, so it will just represent as rows in columns. So that's we will call the data frame. So making data frame, how we will do this? We will define this variable df, that's, and we will I have shown you the example yesterday how we will read the CSV file. So we will read this CSV file using this function pd.read CSV and we will just write the name of CSV file. You can show, we can see in my directory, this is the file nba.csv. So I will reading that file. Then I will create the series pd series, and from that file I have want to just read the name. Just wanted to read the name, and sir dot head dot 10. This means that first 10 elements will be accessed. Okay, when I run this, you can see this first 10 elements will, with the column name will appear. So that's how we access the elements from CSV file. So this is the first step where we will see that how we will access the elements from series with position. Now we will see how we will access elements using label, or you can say index label. So first of all, accessing a single element using index label, right? So we will again import pandas as pd. We will import numpy as np, because we are individually performing here different functions, so that's why we have to import this. But if you want similar kind of operations, you can just execute these libraries once and write the other statements of execution in other cells also. It will give you the result. So using the index label, first will create we will create a simple array. Okay, data is equals to np dot array again. Take another example. Python h n and we will give this array an index and pd by creating a series pd dot series data, and we will assign the index here. Let's then 11, then 12, then 13, 14. How many letters I have? The 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 15. 15. Okay, and now I have to access the element. Accessing the element using index element. Using this index element. Print serial. Suppose I have this. It will gives h. See 10, 11, 12, 13. And on 13 index you will see h. So that's how you will access the single element using index label. Now we will see how we will access multiple element. We will see multiple element using index label. So again, just I am copying this because same code here, because I don't want to repeat these things, and just copy this here and right here accessing multiple elements using index elements. So here I write multiple indexes like 13, 14 and 15. So I will write here multiple indexes. So just run this. What it is saying, see, key of type tuple not found and not a multi-index. Wait. Yes. See, actually, I have to use in this bracket also because a bracket also is. Yes. See, I have this is the multiple indexes. This I have, and this is the whole list. Now this will execute. Okay, 13, 14, 15. And we have elements H, O. Now I will access the multiple elements. First we have generated the data here, but now we will have to access multiple elements using index label from CSV file. So we will again copy that data because we do want to write again and again the same code. We will read the CSV file first. Copy here. We will read the CSV file first, and after that we will write serial, and because yes, it is enclosed in the brackets, and in that you have to give multiple indexes. So 0, 3, 6, 9, suppose represented, and here it will give this uh, result in 0 index. You can see the name here, you can see the in 3 index, 6 index, 9 index. You can also see here at 0 index it is every, it at 3 index it is RJ Hunter. So yes, you can verify it also. So this is how you will access the elements by using the index label, right? Now moving further, we will do some binary operations on Pandas series. We will see how we will perform some binary operations like arithmetic operation. We will DC comparison operation, comparison operation on series. See, also we will see this on the data frames as well. So let's see first arithmetic operation. So we will again import pandas as PD, and we will take first series as S1 PD dot series, and we will so let's take some numbers 10, 15, 20. Okay, and let's also let's assign index also here. Index is equals to, because it will create a data frame, so let's assign a index also as A, B, C, right? And then close these brackets, and after that create a second series PD dot series, PD dot series, and just write over here 2, 4, and 6, and after that assign index here also A, B, C. See, yeah, yes. Now it will. And then suppose we just perform a simple adding, adding two series. What we will do? We'll create a variable over here result and simple just when how you will do this addition s1 plus s2 and you will print the result. You will see the addition of two series 10 plus 2 12 15 plus 4 19 over here and 20 plus 6 26. We have to assign the same index so that we will not get confused in that. Okay, and it is of integer type, so yes, it is here. Now when we perform comparison operations, so let's see that also. We'll take same two series s1 and s2. Okay, there's no need to assign index over here because we have to compare it. There's no need to assign here. Just write this series and I will write here because we are comparing the two series. So we will check that this is this s1 is equals to s2. We will check this and then print result. So yes, it will show false in for all the three elements over here, and its d type is boolean because it is returning false. So it is d types is boolean. So that's how we will perform the binary operations on Pandas series. So now moving further in the tutorial, we will now explore data frames. Okay. Until now we have series operations, how we will create this panda series, how we will create this empty panda series, then from list, how we can create it, and how we can access the elements of a panda series, right? And what can be the binary operations on panda series. So now we will explore data frames. So I have already discussed what are data frames. It is like an Excel file uh, in which we have multiple rows and columns. So let's create first an empty data frame. Let's create first empty data frame. Same as we have created a series. We will import pandas as pd and we will create this data frame pd dot data frame, and now in place of series we will use this data frame. And let's again see, check that it will give future warning or not, as it gives in the series. Let's check that. In this it has not given. So this is the data frame. We have columns and we have index. Okay, so this is how you will create the empty data frame. Now when you want to create a data frame from a list, you want to create a data frame from a list. How you will do this? List is simply, see, we will import pandas as pd, then we will take a variable lst is equals to, suppose I have take Python data analytics. Suppose I have taken this list, okay, and I have just created this data frame using this function pd dot data frame lst, and when I put this df data frame, see what, yes, now you can see here that it automatically assign index values to pass when you pass a list from, and you have also see, you can see this column index also here, assign as 0. So yes, uh, each item in this list becomes a row, okay, and this data frame consists of a single unnamed column, right? So this is how you will create a data frame from a list. And now when you want to create a data frame from dictionary of numpy array, numpy array, you will do that. You will first include pandas as pd, and you will import numpy as np, and then we will create this variable data, and we will create the numpy array using this function np dot array, and we will assign, actually we will assign, see, first of all 1 2 3, then 4 5 and 6, and 7 8 9, right? And we will create a data frame by using this function again, pd dot data frame, pd dot data frame data, and we will now gives the column name. In above program, you have see that I have not given the column name, so it assigned as unnamed column, but and by default it will assign 0 for the column name. But now if we want to create a column name, so this is how you will create. We will just write columns is equals to, and column A, column B, and column C in this form. Print data frame, and yes, you can see here this is the data frame which was created with rows as 0 1 2 index, and the column names are here A B C, and you can see that this is because it is a two-dimensional. I have already told you that it is a two-dimensional, multi-dimensional array data frame. So here you can see this is the multi-dimensional array which is created, right? So I have created this dictionary from data frame using dictionary from NumPy array. Now if I want to create a data frame from list of dictionaries, let's take this example as well. Data frame from a list of dictionaries. So I will import again pandas as pd, and just write over here text curly braces because we have we have we know that list is dictionary in pandas in python, sorry, in python you will create a dictionary like this. You will use curly braces, then you will give a key and give a value. Okay, and because it's a list, so that's why we are giving it in the list form. So let's take an example. Let's take my name, and let's take another example as Aparna. All names starts with A, and let's take another name. This Pankaj. Suppose this. Okay, and so this is the first key in which we have these three values over here, and now we will again we will take the second key as degree. Okay, so as degree I will take, so my highest degree right now is MTech, so I'll write that. Okay, MTech, and suppose Aparna is doing right now MBA. I'll write MBA, and for Pankaj he is BBA. It's okay. And third key I will take school, how much they have scored. So I'll score myself highest 90. I'll score 90% in MTech. And Aparna has scored, let's say, 60%. I don't want anyone to be in my range of scoring. So I'll be the highest scored person. And for Pankaj, I'll take 40, say 40%. Right. And then we will create this data frame here and write the variable, call the variable printf. Let's see, you can see index for rows are 0, 1 and 2, and we have assigned the column names, we have assigned the keys. So it will take as a column name, degree and score, and the values are filled here accordingly. So that's how you will create a data frame from a list of dictionaries, right? So moving further, we will see how we will access the uh, pandas data frame. So we will see over here how we will access the data frame in pandas. Access data frame. It means how we will retrieve, how we will explore, and how we will manipulate the data stored within this structure, right? So first of all, I will display the entire data frame, which includes all rows and columns, so that you can understand. We will use this import pandas as PD, and we will create a data frame. We will variable. Here we will give this name, John, Alice, Bob, Eve, and Charlie. Suppose I have taken these names, and then I have to identify their age. I have to give their age. Key value is enclosed with single quotes. Don't confuse this. Okay, so in that I will again this 25 for John, 30 for Alice, 22 for Bob, 35 for Eve, and 28 for Charlie. Now I will mention their gender. So John as male, then Alice as male, then Alice is female. Female. Bob is male. And Eve is female. Female. And Charlie is male. I will identify their, I will give their gender, right? Close the bracket, and I have to now assign the another key as how much they are earning. Okay, so 50,000, that's 55,000, 40,000, 70,000, 48,000. Now I will create a data frame using this have to close these brackets also. Have to close these brackets. Braces. And again now. Yes, I will create a data frame. Data frame. Call the variable data, and this it will display the entire data frame. So this function. Let's check this. I think I made a mistake in assigning this. All arrays must be of same length. Wait, let me check. Let me check this. See, I have taken here name as John, Alice, Bob, Eve, Charlie, age 25, 30, 22, 35, 28, gender here. It's what it is saying. First, we have to say all arrays must be of the same, and I think I have missed something. See here, I have given only 4 elements here. So why I have not Charlie, his salary, he is earning 48,000. Suppose. I think it's sorted now. Just run this, and you get this data frame. Okay, you have this 0, 1, 2, 3, 4, and as rows, and you have this name, age, gender, salary. So you will have this entire data frame at a time. You can see the multiple rows and columns here. Now the operations are beginning now. Okay, now when you just want to access columns from data frame, see, when you want to access the column, any column, so I'll just write the comment here, access the, suppose you want to access each column. Okay, so how you will do that? You will just give the column name age, that I have to access this age column underscore column is equals to डेटा फ्रेम में इसको बता दीजिए मुझे एज, राइट, डेटा फ्रेम में एज देख के बता दीजिए प्रिंट एज कॉलम. ठीक है, see here it will give this only age column over here 25, 30, 22, 25, 28. It will give this, and when I want to access rows by index, see, when you have to access specific rows in a data frame, so you will use ILOC, or when you want for positioning indexing, or LOC for label and paste indexing. So let's take a look on that also. Access the row at index 1, index 1, index 1. So how we will do that? Mean second row, obviously we have seen the first row has index 0 and second row has index 1. So print, first of all take this variable second row is equals to df dot iloc. So when we use this iloc function, it means we are accessing the element using index, right? And when we just write the loc function, it means we are using the label based indexing. So df dot iloc and 1, and print over here second row, and here you can see here second row is name, age, gender, salary, and you will have these values: Alice 30, female 55, right? You will get these. And now if you want to access multiple rows or columns, how you will do that? This, so these are the some basic operations. I will give you the links and the references where you can go and explore all these methods, how you just play with these methods, so you will understand how you will get the insights of the data, okay, by performing various functions, various methods. So because there's a lot of functions, and again I can't able to cover all of these here, so I just suggest you to uh, go there and practice uh, on your own, right? So here I have to access multiple rows and columns, okay. So suppose I want to access the rows first three rows. How you will do that? We will make a subset and we will create a data frame with the label based indexing, sorry, label based, using the based indexing, that is .loc, sorry, .loc. And I will tell you what I'm doing here: 0, comma 2. Then this is example, and again I will write here name, age. Suppose I have to access these three: name, age, and I will print subset. You can see here 0, comma 2 means you have to start with 0, zeroth row, and ends at 2, okay, ends at 2. So yes, here it is, it starts with 0 and ends at 2, and you have to take only these columns. So I'm accessing the first three rows, so I will give this label based indexing. I will give the range, you can say here, and that it should start with 0 and it should stop 2. So it means that it will access the first three rows, and in that first three rows, I want these two columns to get printed: name and age. So you can see here is it will print the name and age. So that's how you will access the multiple rows and columns. Again, there is another example also. If I want to access rows where age is greater, suppose access rows where age is greater. So greater than 25. It means we are filtering on the data on the basis of some conditions. Okay. So we are accessing rows based on conditions. So what we will do, we will do filtered data here is equals to then data frame, then df age, and we'll see here is it greater than 25. We will give this condition, and when we print this filtered data, see, you will get the output where age is greater than 25, and is even shortly you will get this output. So that's how you will done access. You will access multiple rows and columns. Okay, by manipulating the data, by retrieving the data, you can do this pandas access data frame. So another example can be indexing and selecting data with pandas. How you will do indexing and you will select the data. Indexing and selecting data. Let's see that also. Now indexing and selecting data help us to efficiently retrieve specific rows, columns or subsets of data from a data frame. Whether we are filtering rows based on conditions, extracting particular columns, or accessing data by labels or positions, mastering this technique helps to work effectively with large data sets. So first of all, we will see how you will do this indexing with the bracket operator. I have to tell you. Indexing data using the this big operator. Okay, operator. So first of all, when you want to select a single column, when you want to select a single column, how you will do that? We will see here. Now I am importing the CSV file. First of all, I have to import pandas as PD, and in data I will just read my CSV file which I have read before also. So I will just write pd dot read CSV, and I will write here content slash nba dot CSV. No, I want to read that, and I just want from that NBA CSV file name column to be read, okay, to be accessed, you can say. So that's why I have written here that the from the NBA CSV file you have to take the content, and what you have to index should be, it should be name, right? And after that, print data set like this. Print data set. Now display parameter data dot head, जिसमें first 5 elements हों हमारे, ठीक है, ये हो जाएगा. First it will display the first 5 elements, okay, by using this function. After that, when I will write here first is equals to data, you will get to know this after you will see this output, so you will understand what has been done. Data age, I have to fetch this single column, no? That is age. So then print what, new line, single column, selected from data set, and display first dot head. Again I found this error. What it says now, it says here it says something fishy. Data is equals to pd dot read csv and content dot see, no such file or directory. Wait, see, you can see here firstly it displays first 5, right, first 5 data as first 5 rows. When I have written here display data dot head, and I have given this range also here, so it will display first 5 rows of this data set. Now I have written here uh, I have to fetch these first. I have declared the variable here as first, and in it I have taken age as a label position, as a label, okay, uh, as a label index actually. So when I will again write here display first dot head, and I will give this here the range over here as 5, so you can see here it will give name, and it will give the column. So I had selected single column from that data set. That's how you will do this, right? So this is how you will done indexing and selecting the data using this operator. Now moving further, now we will not doing not more operations right now, because the next thing is in that it is slicing the data frame, so it will again implement the same concepts as it will implemented in the series. So I will not repeat that. You will understand by when you go through the PPT. So back to our PPT. Just wanted to share my screen. The PPT. We have seen this how we will access the element. We have seen this slice operation. We have seen this last how we will access the data. Right, we have see binary operations. Right, so because there are many functions, so I want you to explore these methods and practice yourself so that you can understand how you will get this insights of the data. So this is how you will get this by this indexing with .iloc. I know when you write here in iloc as 3 means third row will be printed, third column will be printed here. So here are many more methods also. DataFrame.iat which accesses a single value for a row or column paired by integer position. Then we have this DataFrame.pop which return item and drop from data frame. Then we have DataFrame.xs return a cross section rows or columns from the data frame. Then we have this DataFrame.get which get item from object for given key, and DataFrame.isin return a boolean data frame showing whether each element is contained in values or not. So these are some methods. So I want you to practice these methods because there are many more and I can't show you in this given time over here. So just explore these methods and practice on your own. Okay, and the same this slicing concept will implemented in this as it has implemented in the series. So we will implement as the same slicing pandas. We will slice using ILOC, we will give this index position and we will also we can also slice columns and data frames. Okay, while keeping all rows. This colon means it will keep all rows when we write this colon. So it means that you have to select all rows. Okay, and column means here you just access 0, 1, 2 column. So this is sorting. I want you to practice this. This PPT will be shared with you. So we will have sorting pandas data frame as well. You will, these are some parameters. How you will sort values. You know, see when we have to sort a data frame by multiple columns. So we just create this data set over here and we will sort values by we will see you can see here now by specifies the column to sort by. So we have used this by parameter that we what we have to how this sorting should be done, and we will give this column name over here age and score, and then we will print this. So you can see here you will get to see you will get age and score, right? It will sort the data like this, and then we have some this we have created this data set. So you can see here there are some missing values also. So by default sort values places null values at the end by default, and if we need them at the top we can use the any position parameter. So here you can see here first of all we have to you will see this you will not see this entire data frame as I am not attaching this the output You will practice on your own. And see here, I have written here df nan dot sort values and sort the array by age, and its position I have defined that you have to uh, put it first. So you can see that in the age it will come here in the first position. So here are some other how when you will choose a sorting algorithm. So you just uh, write here kind is equals to quick sort. So by implementing the quick sort, it will generate the output accordingly. Now here are some pros and cons of pandas. So you can see uh, for pros of pandas that it is very simple syntax even for the complex operations. You will understand is it is easy to use. It has powerful data structures like series and data frames that handle structured data well. Then it has rich functionality which supports cleaning, transformation, and analysis. And then it has this feature of file handling also, which can read these files, whether it will be CSV file, whether it is Excel file, whether it is SQL file. Then it can also integrate with NumPy also, and in the upcoming session I will also use this with matplotlib to get this visualization of data also. uh, but there are some cons also over it. And what are that it is not ideal for very large data sets. So for large data sets we have Dask and Spark, right? So it will these tools will are very useful for the large data sets. And also you can see this learning curve. It means beginners may find too many functions overwhelming. So when I repeat that LOC function, so it is kind of overwhelming on users to repeat that functions again and again. So yes, the primary cons of pandas, we can say that it is not ideal for very large data sets. So, all right, we have wind up this pandas session, right? Now, what if we own, now we see how pandas help us handle data in a structured Excel-like format. But what if we only need to deal with numbers? And what if we want to perform fast mathematical operations like linear algebra or work with multi-dimensional arrays like matrices? So, I'm not, so that's where NumPy comes in. So NumPy stands for numerical Python and is used for handling large multi-dimensional arrays and matrices. Okay, it is the backbone of many data science and machine learning libraries. Even Pandas is built on top of NumPy. So in Pandas, we work with rows and columns of data, and in NumPy, we focus on arrays, powerful, multi-dimensional structures that are much faster and more memory efficient than Python list. So with NumPy, what you can perform, you can create and manipulate arrays, you can perform element wise and matrix operations, you can generate random numbers, and you can perform statistical calculations, you can conduct linear algebra, and many more things you can. So imagine, to make it more relatable, imagine Pandas as your Excel workbook where everything is structured into sheets and tables. But NumPy, on the other hand, is like your scientific calculator that can crunch numbers at lightning speed. So, in this session, we will explore how to create NumPy arrays, understand their attributes, and see some of its operations as well. Right. So, first of all, Because we are dealing with numpy, so we have to understood which type of arrays we have to deal with. We have one dimensional array, which is a type of a linear array. So when you just want to import, how you will do this, so just import numpy as np and create an array a is equals to 1 2 3 4. And how you will create an array in numpy, you just write this function np dot array and print. First of all, you will print the list in Python, and then you will print numpy in numpy array in Python. So this is how you will get this output. And then we have multi-dimensional arrays, which stores more than one dimension, such as rows and columns. So we have created this three list over here. List 1 contains 1 2 3 4 as 4 elements here. Then list 2 contains 5 6 7 8. Then list 3 contains 9 10 11 12. And after that we will create numpy array. So we have created this variable which contains this numpy array, and then we will create this array np dot array, and just write the list name over here, list 1 list 2 list 3, and you will get this output like this. Okay, so without wasting any time, I have to share this my Jupyter notebook with you. And I am now creating a new notebook. It is like this previous notebook is already saved here. I will give the name NumPy tutorial. Right. I will rename it NumPy tutorial. So yes. So first of all, we will see the different ways of creating NumPy array. So I'll just make it a heading. Creating NumPy array, different ways. So first of all, we will use this numpy.array function. Okay. So what we will do, we will numpy as np, and we will create this variable numpy add add, and we will use this function np.array, and inside this we will take some elements 3 4 5 6 and print array and the values. So yes, you will get here. You get this. This is the simple way of creating the numpy array. Okay. Now we will use this another function. We will use this another function. Let's see. Import numpy as np, and we will take a variable, and I'm taking the reference from geeks for geeks, so I'll write here geeks for geeks. Okay, I'll write here geeks for geeks, then array. I'll create this array np. Now I am using this function numpy numpy sorry from iter np dot from iter. I am using this function from iter, and what it does, and from the variable, and I am also assigning the data type. It should be Unicode because it is a string. That's why I am using this data type. And why I am using this 2 over here, it means that each you can say each character will store 2 memory space, but it doesn't matter if if I not write 2 over here. When I will use only u, it will also run execute this string, because actually it from this string it will create the elements of the array. So it will be a single character, so it will it is fine if I only write u also. Okay, so when I print this from item and the value, see, from this variable geeks for geese, it creates a numpy array in which it contains these elements geeks for geeks. So this is how you will um, use this uh, from iter functions. Then I have this arrange function. I want to show this. What this is a inbuilt function. Okay, it is similar to the range function. Let's take an example for that also. Import numpy as np, and we will just write np dot arrange, and we will write here this one. It should start with 1 and it should stop at 20, means before 20, and it should take 2 steps as an increment. After that I will specify d type also, that it should be of float type. Suppose float type 432, p dot 432. Just see, you can see here that it will create an array of float type, and also gives you this data type that it is of float 32, right? Now I have this again this numpy dot once method. That also import numpy as np, and np dot once. This function is used to get a new array of given shape and type filled with ones. Okay, so how it will recognize shape, because we will give this value over here 4 comma 3. It means I have given the shape of an array as it should contain 4 rows and it should contain 3 columns. So it gives this shape of the array as rows into columns. Okay, so let's see that, and I have also write that d type should be integer, np.int 32. After that, order np. Okay, see, it will create an array with 4 rows and 3 columns, and they are all of integer data type, right? So you can see over here. Now, we will discuss about array attributes. What are the NumPy array attributes? So we will discuss about that. NumPy array attributes. See, the shape function has come now, so you are not able to fully understand that. So NumPy array has some properties that describes its structure. So we can access them using dot notation, like I have done here, dot ones, dot range. So we can also access the structure of the NumPy array using the dot notation. So first of all, we will see ndim means it will tell number of dimensions in an array. These are some very basic attributes, right? So it tells that how many dimensions the array has. So let's take an example. We will import numpy as np, and we will create a simple array np dot array, and just write 2 3 and yes, 4 5 6. Okay, and when I will print like this, add dot ndim, so what it will give? It will give 2, because it's a 2D array, right? It has it's a 2D array, matlab, it has 2 rows, 3 columns, so it's a 2D array. That's why it gives the number of dimensions, 2D. Now if I want to check the shape of the array, if I want to check the shape of an array, how you will do this? I just here, because I have created this array now again, so I will print over here add dot shape, add dot shape. So it gives me shape, prints the shape of an array. So let's see this. Yes, you can see here it has 2 dimensions. For when I have written number of dimensions ndim, when I have used this attribute, so it tells that how many dimensions the array has, and when I want to know the shape of this array, it gives me like this, that it is 2 cross 3 matrix. It has 2 rows and 3 columns. And now when I want to know the size of the array, how many elements are present in the given array, so how will I do this? I will just write add dot size, or yes, I will just write this add dot size, and it will print the size of the array, inside the array, sorry, inside the array. See, we have 6 elements, so it gives the size as 6, right? Now I want to know the data type. What kind of what kind of data type it has, which kind of data type values are present here. So I will write here again print add dot d type. So yes, I will get this int 32. It means the array stores 32-bit integers. Okay. Now I want to transpose this. I want you have studied transpose of matrix, when rows becomes columns and columns become rows. So how we will do that? We will first of all make this clear. Friends, data type of elements, then print here array dot you will dot t. For transpose, you just read this tree. So you will see prints transpose of array. See, you can see here that the row becomes columns. It gives the output like this, right? It gives the transpose of the given matrix. So this is how you have, this is some of the attributes of numpy array. Now we will discuss how you will done indexing and slicing in numpy. Again is the same method. I just now not going deep into that. I just give you this overview how you will do this. So indexing means accessing a particular element from the array using its position, or you can say index. So again, for 1D array, I will take the example for 2D array, because for 1D array it is easy. I will take example from 2D array. So 2D array, you will import numpy first as np, and you will create an array is equals to np dot array, and you will, what you will do, you will create the array elements attributes. One comma 2 comma 3, and we have 4 5 comma 6, we have 7 comma 8 comma 9, right? Yes. So this is how I have created. Now I am accessing the array by position, like 0 comma 1. Okay, 0 comma 1, and I want to access array output will be 2 and 9. Means this array will print elements at first row and second column. It will access that, and this will access elements at third row, third column. Okay, so this is how you will, means row will be 0 and column will be 1. So see, row will be 0 and column will be 1. So that is why 2 is printed here. And here row will be 2, right, and column will be 2. So 0 1 2. Okay, 0 1 2. This is 0 2 and column also will be 2. So 0 1 2. So here you can say this is third column. Okay, so it will print 9. Now how we will do slicing? Slicing means selecting a range of elements from the array using the format. So we will start again. Let's take an example of import numpy. We will create array is equals to np dot 20, 30, 40, 50. Okay, and when you want, I want to do slicing of an array. So when I write here array, and when I will give the range 1 is to 4, that means it will prints the elements from index 1 to 3, right? 4 means stop. So before index 4, it will print the array element, sorry. Then I will write here, if I write here array, and I will give this range, I will just give this colon. So it means it will take all rows. But when I want to I have taken this 3 over here, so you will see in this on the output what it will print. Will take print the elements from beginning to index 2, right? Okay, this is the row and this is the column. So it will print the index, it will print till 2, index 2, 0, 1 and 2. Okay, so the output you will get 10, 20 and 30 over here. Now if I want to print, I'm slicing this array, add 2 comma, it means it will take what? It will take index, it will start from index 2 till end. Okay, print, it will print the elements from index 2 to end, right? So let's do this. Yes, you can guess this. we have this index over here 0, 1, 2, 3, 4. So when I have right here range 1 is to 4, then it will print yes 20, 30, 40. And for array, colon means it will take all the rows, but I have assigned this stop, so it means that it will print the elements from beginning to index 2. And when I write over here that you have to start from index 2, but you can I have not specified the stop function here, stop element here, so it will print the elements from index 2 to end. So this is how slicing works. Now if I want to reshape my array and resize my array, reshaping and resizing the array. How you will do this? Reshaping and resizing. Reshaping means the changing of the shape. Means rows and columns. Shape means rows, columns, and dimensions. So when we modify the shape, when we modify this rows and columns of an array without changing its data, then we will say that we have reshaped the array. So before doing this, you have to understand that data total number of elements should be the same. Okay, and we will use here dot reshape function. How you will do that? We will import numpy as np, and we will create an array np dot array, right? We will get 1, 2, 3, 4, 5, 6, and we will reshaped. We have taken the variable name as reshaped, and now we are reshaping using this function called reshape, and I am saying that convert it into 2 comma 3, that is convert it into 2 rows and 3 columns, right? And now when I want to print this, let's see what output I will get. See, the data remains the same. See, I have all these 6 elements 1, 2, 3, and 4, 5, and 6, but it has reshaped this array with 2 rows and 3 columns. It will make that, right? Now I want to resize my array. Resizing means changing the shape and size of the array. So, but in reshape, uh, unlike reshape, it can add new elements. Means if the new shape is largest, then it can add also new elements, and it can remove elements if the new shape is smaller, and done using dot resize method. So let's do that. I have to reduce the size now, so I will again import numpy as np, and what I will do array dot np dot array. I will create this array 1, 2, 3, 4, 5, 6, and then I will use this resized function. Resize is equals to np dot resize, and in array I will write this 2 cross 2, make it 2 cross 2. First I have written here na 2 comma 3, so it means 2 rows and 3 columns. Now I am reducing the size. I am saying that just give 2 comma 2. Now I will print resized. Okay, what I have seen. I have forgotten two post and also yes, here it says see 1 2 3 4. It reduces the size of an array. It only shows now 2 rows and 2 columns, and also uh, drop the data also. As I have said earlier, that reshape done the removing of the elements also. If we will reduce the size, so yes, it will remove some elements to make this size accordingly. So that's how we will reduce the size. So yes, this is the basic reshaping and resizing the array in which we can use in this numpy. These are the very basic operations I'm showing you, and we can also do mathematical operations in numpy. I'm not now going to that basic arithmetic like addition and subtraction. You can see here array operations. Array operations. So we have some basic operations and basic methods. Let's do the matrix operation. I'm not doing right now the basic arithmetic and comparison. You all know very well. So what I will use, we will use just first matrix x np dot array, and I will assign the functions here 1 comma 2 and 3 comma 4. Okay, 3 comma 4, and again I will take this y variable and assign the function 5 comma 6, and we should also include 5 comma 6 and 7 comma 8. Now I am print c x dot y. It means this dot function, what it this dot function do, it will multiply x by y. So we are doing actually matrix multiplication here. We are doing matrix multiplication, and when I write print np dot transpose np dot transpose of x, so it will transpose the matrix where row become column and column become row. See, first it will do the matrix multiplication x dot y, and then you can see here that here the rows becomes columns and columns becomes rows. So this is how you will do the basic array operations. So back to our PPT. Back to our PPT. Yes, so we have seen all these operations different ways of creating arrays by using these different methods, and we have discussed array attributes as well. Then we have done indexing and slicing, and these are some of the basic array operations. I have not done this addition and subtraction, or you can some of these minimum maximum standard deviation. You can practice this on your own. Just explore these methods functions, sorry. So just explore these functions and see how it will all done. So before we end today's session, let's quickly reflect on what we have learned together. uh, First of all, we have see pandas, which have labels and meanings. We learn two structures series, which is just one column, and we have the data frame as a second data structure, which is a kind of a whole spreadsheet. And we so pandas is like is organized, it is meaningful, and it contains real world data analytics. And then we move to NumPy arrays. It is like super fast container for numbers, faster and efficient than normal Python list. So uh, together NumPy and Pandas form the foundation of data analytics in Python. NumPy gives us the speed and math, and Pandas gives us structure and usability. So with NumPy and Pandas, your data is no longer just raw numbers. It becomes fast, organized, and ready for insights. And this is the very first step towards becoming a data analyst or data scientist. So these are some references you can take. And if you have any query, you can ask. Thank you for now. We will meet again tomorrow.